Hi everyone. So today let's solve a Leetcode question called clone graph. So what is clone graph? Well, let's look example here. In this example, the original graph in clockwise order is 1, 2, 3, and 4. Now, in this kind of scenario, we also have this 1, 2, 3, 4 in the same order. However, the nodes are exactly the same from the original graph, so it's copy instead of clone. And in this scenario, the nodes are the new ones, and the node values is also 1, 2, 3, 4. However, the topological structure of this node are completely matched with the original graph. And what do we want for the clone graph? There's three requirements. Well, the first requirement is that the node values should be same. So 1, 2, 3, 4, and here should 1, 2, 3, 4. And the second requirement is that the nodes are new and not a simple copy paste from the original graph. So you see here the nodes are all yellow, these are all blue, so these are the new nodes. And the final requirement is that the topological structures, in other words, how nodes are connected with each other, should be exactly the same with the original graph. Okay, now we get a sense of what does clone node means. Let's dive into how to solve this problem. Well, for this kind of problem, I mean the graph problem, the most efficient way is to use depth search or breadth search the solutions. Our intuition to this problem is that we will traverse, for example, here we'll traverse each row in original graph. If found okay, this node is previously not visited, we'll build the new nodes in a new graph and we'll map the original nodes to new node in dictionary. And after that, we will check and append all neighbor nodes in the original graph to the clone graph. So the depth search works. And finally, we found, okay, the previous element is visited, for example, where visited is 1, 2, 3, 4, and go back to this one. This means we finish the entire loop. We have to return the clone graph. Now, let's make a simple drawing to help you understand that. Okay, so first, let me draw the graph for the dictionary. For the dictionary, we must have the keys and values, right? The dictionary like this, and let's draw the original graph. Starting at 1, this is 2, this is 3, right? And the final element is 4. Okay, the original graph is finished. Now let's keep visiting the original graph. So first we'll visit this one. We found okay, this one is not previously visited. So we'll first add these two key. Then we'll build a clone node in the new graph. The clone node will build the one here. Then we want to check the second element because run depth search will want to check all the neighbors, right? So you see the one's neighbors, the first neighbor is 2. And 2 visited, not 2 is not visited. So we want to add this one to here. 2. Oh, sorry, we miss out adding a dictionary element. The dictionary element, before we had this 1 here, right? And visited 2. In the original graph, we have 2. And we clone the graph, we also have this 2. We use the original color to help you understand that. We got 2 here. Now with the 2, so what is neighbors? Next neighbor? Next neighbor is 3, right? So visit is 3. And found okay, 3 is previously not visited, so add 3 to this key. And we also want to build a clone graph for this 3. So we just clone this 3 and want to add 3 to here in the veil. And finally, so what's the next neighbors after 3? Well, after 3, we get 4, right? So 4 is not previously visited, so we also add 4 to this key. And we want to build a clone graph for this 4. So we also want to add 4 here and write 4 here. And finally, we want to check, okay, what's the next element of 4? Well, next element 4 in the original graph is 1, right? However, we found the 1 is previously visited. So we just make a connection for this 4 and 1 to here. And since 1 is already visited, we have to return this entire clone graph. Okay, so this is the clone graph we want, and we just return. Okay, now you get intuitive sense of what does clone graph means. Let's dive into the actual code. Okay, so first, let me write the general framework for solving this kind of graph questions, and then write a helper function. But first, we need dictionary. Dictionary with a key as the node in the original graph and the values as a node in the clone graph. And now let's call this help function, which I'll write later. Pass it the node and first variable and dictionary and second variable. Let's record its result and result so we can return this one. Now finish the main function, let's dive into how to solve the help function. The help function, as mentioned in this line, will have node as first variable and dictionary has the second variable. Now, first scenario is that we have no node, right? We have to immediately return null because we don't have node in original graph. We also don't have a node in the clone graph. Now, second scenario is that we have already visited all the node, so we have to immediately return to avoid the duplicate. And the third scenario, so let me copy paste here to save time. We want to build that node and want to map the original node to the clone node. And after that, we want to check and append the neighbor nodes. So this is how DFS search works. And finally, return the clone graph and should finish. Now finish the coding comments. Let's write actual code. So there's no node, we just return null. If bank here is visited, so this means if node is already in the dictionary, we want to return a dictionary with a node. And after that, we found node is not visited and there are at least actual nodes in the original graph. We want to actually build the clone graph. So let's say the clone node using this node function and passing same values. So it will be the new node but with the same values. And we want to map the original to the clone nodes, right? So you pass dictionary, the key will be original node and the value should be the clone node. And after that, we want to check all the neighbors to go through the DFS search requirement. So for neighbors in original node dot neighbors, yeah, and we want to inherit the same topological architecture for the clone node. So clone node dot neighbors and use this append function in Python. And now we want to pass this helper function and with these two variables. However, this node here to change into neighbors because we want the neighbor nodes, not the original node, right? Okay, now finish this one. Let's return the clone graph to see it works. So before submitting code, let's make a simple check to see if the type works. And let's submit the result to see it works. Okay, you see the time complexity, memory usage is not bad, and the solution is relatively easy to understand. Okay, I hope my explanation are helpful for you, and I'll see you next video. Thank you.